So this particular sum, we have the curve with parametric equations x equals to 2 cot t and y equals to 2 sine squared t. So the first thing that we have to do is find an expression for dy by dx in terms of t. Now you remember that dy by dx for parametric equation is dy by dt divided by dx by dt. So that by chain rule becomes dy by dt multiplied by dt by dx. So this dt cancels and we get dy by dx. So that's how we get the derivative for parametric equation. So the first thing that we have to do is we have to find dy by dt. So if we differentiate y, so y equals to 2 sine squared t. So therefore, the derivative of y in terms of t is dy by dt. Remember, we are not differentiating in terms of x, we are differentiating in terms of t. So here we have a power. So the rule for derivative of power is this one. So remember, d by dx of ax plus b to the power n is going to be n, then ax plus b to the power n minus 1 into the chain rule d by dx of ax plus b. So that's what we have to do here. So in this particular case, we have this 2 as the power, this 2 as the constant, and this 2 as the power. So the power comes first, so this 2 would come first, and then we write the same thing with the power decreased by 1. So if the power is 2 here, if it becomes decreased by 1, it would become only sine t, and then d by dx of the algebra, whatever is inside the power. So inside the power we have sine t, so we have d by dt of sine t. So that's what we have to do here. So now if we simplify 2 to the 4, sine t would be sine t, and d by dt of sine t is going to be cos t. So dy by dt is 4 sine t cos t. Next we have x equals to 2 cot t. So therefore we have to do the derivative. So d by dt of x is dx by dt equals to now the derivative of cos. Now if you remember from C3, d by dx of cot ax is minus cosec square ax into d by dx of the chain rule, the angle. So remember, the derivative of cot is minus cosec squared theta, whatever the theta would be here. So by that formula, the 2 would be 2 and this would be minus cosec squared theta. The angle is t here, and d by dx of the chain rule t is going to be 1. So this would be minus 2 cosec squared t. Now since we have found both dy by dt and dx by dt, so we have to find the derivative now. So therefore dy by dx is going to be dy by dt divided by dx by dt. So this is going to be dy by dt is 4 sine t cos t, and dx by dt is minus 2 cosec squared t. So this 2 and this 4 cancels, 2 to the 4, so we have minus 2. So we have sine t, we have cos t, and this one cos squared downstairs. If you remember the identity, again the C3 identity, the identity says that 1 by sine theta is identical to cosec theta. So cosec theta is the reciprocal of sine theta. That means sine theta is also the reciprocal of cosec theta. They cross multiply. By that rule, we can easily say that the cosec squared theta downstairs, meaning 1 by cosec squared theta, if you bring it upstairs, it would become sine squared theta. That means minus 2 sine into sine squared theta is sine cubed theta. I am referring to theta as the angle here. That angle is t, and cos t. So the derivative of the gradient of this is minus 2 sine cube t cos t. Now we have to find the equation of the tangent to the curve at the point t equals to pi by 4. Whenever we have to find the equation, we have to remember the rule for C1. So the C1 rule says, let me scroll down here. So by the C1 rule, we remember equation of a line is, if you have this and x1 y1 and this is the gradient, so the equation of the line is y minus y1 equals to m x minus x1, and the gradient rule for a tangent is that gradient of tangent equals to the gradient of the curve at a particular point. So this is the gradient rule, meaning this is how we calculate the gradient m, and when the point is given we can easily find the equation of that line using this formula y minus y1 equals to mx minus x1. So here the question is, find the gradient, find the equation of the tangent. So for the equation we need two things. We need the point through which the line passes, and we also need the gradient of that particular line. So at the point t equals to pi by 4, so for question number B we can write at t equals to pi by 4 dy by dx equals to minus 2 sine, here we put pi by 4 whole cubed, sine cubed means sine theta whole cubed, and cos pi by 4. So minus 2, again from a triangle we can easily see, from this triangle, this is a C2 rule, if this is 1 and this is 1 and the Pythagorean theorem says this is square root of 2, this angle is 45 degree. So by sine 45 degree means pi by 4 is opposite by hypotenuse 1 by square root 2, and cos 45 degree is adjacent by hypotenuse 1 by square root of 2. Pi by 4 means 45 degree, 180 by 4 means 45 degree. You have to memorize this. This is a rule from C2. So what happens here is that sine pi by 4 is 1 by square root of 2, so 1 by square root of 2 whole cubed, and cos pi by 4 is 1 by square root of 2. One thing is important, the third rule, 1 by square root of 2, 1 by square root of 2, if you multiply upstairs and downstairs with square root of 2, it becomes square root of 2 into 1 square root of 2, and square root of 2 into square root of 2 is 2. So 1 by square root of 2 and square root of 2 by 2 is the same thing, just different ways of writing it down. By simplifying this, we get minus 2 1 by square root of 2 to the power 4, that means minus 2 1 by square root of 2 whole square into 1 by square root of 2 whole square, that means minus 2 1 by square root of 2 whole square means 1 by 2, and 1 by square root of 2 whole square means 1 by 2. This 2 and this 2 cancel, so we get minus half. So if the gradient of the curve at the point t equals to pi by 4, remember this is the parametric format of a point. A point in Cartesian has an x coordinate and the y coordinate. So if the curve has gradient minus half, so the gradient of the tangent, would be the same, because the gradient rules say that the gradient of the curve at a particular point is the same as the gradient of the tangent at that particular point. So now we have the gradient, we need the point. So at, again, t equals to pi by 4, we need the value of x. Now x equals to 2 cot t. So 2 cot t. So we know the identity cot t is cos t divided by sin t. Again we have this identity, cot theta is identical to cos theta divided by sin theta. Tan theta is identical to sine theta by cos theta, and the relationship between tan theta and cot theta is that the reciprocal of tan theta is cot theta. So these are the identities that we need to do. So here, when t equals to pi by 4, you can plug it in here. X equals to 2 cos pi by 4 divided by sine pi by 4. So we know from previously cos pi by 4 is 1 by square root of 2, and sine pi by 4 is also 1 by square root of 2. So we can cancel this, and the x coordinate is 2. Now we need to find the y coordinate. So y equals to two sine squared t. So 2 sine squared t means sine pi by 4 whole square. So this would be 2 1 by square root of 2 whole square. This would be 2 1 by 2. This 2 and this 2 cancels, and this is 1. So the point that we are looking for here, but the parametric value is pi by 4, the point is x coordinate 2 and y coordinate 1. Now we can find the equation of the tangent. So equation of the tangent is y minus y1, which is 1, equals to m, the gradient was minus half, into x minus x1, which is 2. So we can now simplify, multiply by 2, it would be 2y minus 2 equals to, we have minus 1 left, minus 1 into x is minus x, minus 1 into minus 2 is plus 2. So we can further simplify this and write 2y equals to minus x plus 4, or we can write 2y plus x equals to 4. Remember, if they do not mention any format of the equation of the line, you can just keep the line as you want it. The final question is, find a Cartesian equation of the curve in the form of y equals to fx. That's the final question. So x equals to 2 cot t, y equals to 2 sine squared t. Let me scroll down here, move here. X equals to 2 cot t, y equals to sine squared t. Let me double check. 2 cot t, 2 sine squared t. This is 2 sine squared t. Okay, so from here we get x by 2 equals to cot t. We get an expression for cot t, and from here we get y by 2 equals to sine squared t. So we have an expression for cot t and an expression for sine squared t. So let's write down the identities that we have. Remember, whenever we have to convert the parametric equation to Cartesian, we need some sort of an identity to connect the two. Now the identity with cot theta is cot squared theta plus 1 equals to cosec squared theta, and sine squared, we also know that identity, that cosec squared is 1 by sine squared theta, because they're identical. So we can easily use this identity to put these two and have the Cartesian equation. So cot squared t plus 1 equals to cosec squared t. So at cot squared we can just plug in x by 2, so x by 2 whole squared plus 1 equals to, at cosec squared we can write, cosec means 1 by sine squared t. That means x squared by 4 plus 1 equals to 1 by sine squared, we can put y by 2. So that means x squared by 4 plus 1 equals to 2 by y. Now we have to express the answer in the format of y equals to fx. So now what we have to do, first of all we can multiply both sides with 4 to get rid of this 4. So we can write x squared plus 4 equals to 8 by y. So 4 into this, 4 cancels, we have x squared, 4 into 1 is 4, 4 into 2 is 8, so 8 by y. So we can cross multiply, send the y upstairs and this expression downstairs. So we can write x square plus 4. So this is the expression we have been looking for. So y equals to 8 divided by x square plus 4. This is the Cartesian equation. There's one more question here. It's about the domain of this function. Domain is something that makes something possible. So restriction is there. So when you have a domain, the question is for what values of x we have a value of fx, an output of fx. So if you have no output, that means that domain for that function is not possible. For this particular domain, if you put the value of t here, t equal to 0 here, so let me put it here. Of course we can also find the domain from this Cartesian format, but it's easier to use that domain. So we have the values of t, so x equals to 2 cot t. So 2 cot t means 2 cos t by sin t. So if you put the value of t equal to 0, x becomes 2 cos 0 divided by sin 0. So cos 0 is 1, sin 0 is 0, so it is 0. Actually this particular value, nothing can be divided by 0. This is undefined or cannot be determined. So this is one value. If you put t equals to pi by 2, x equals to 2 cos pi by 2 divided by sin pi by 2, so this is going to be 2 cos 90 degrees 0, sin 90 degrees 1. So 0 divided by 1 is 0. That means we can have a range of value of x which is greater than or equal to 0. Of course it's not very obvious what it is going to be. It's more helpful if you have an idea of the sketch of cot theta, but it's a quick way of finding the domain here.